Two popular local whisper tools promise fast transcription without sending a meeting to a cloud service. But they are built for different jobs. Faster Whisper gives Python teams a rich pipeline around C Translate 2, including batching, word timestamps, and optional voice activity detection. Whisper.cpp is a compact C and C++ implementation designed to run almost anywhere. On this Windows CPU test, both produce the same word error rate. Whisper.cpp finished the clean sample about 13% faster. My short verdict is this: choose Whisper.cpp for a lightweight local utility or broad device support. Choose Faster Whisper when transcription is one step inside a larger Python workflow. Here is the benchmark. I used a 75-second English narration created locally for the previous Office AI Verdict episode. It contains 201 reference words, product names, numbers, and business language. I converted it to 16 kHz mono WAV. Both implementations use the English-only Tiny model family on the same machine with no GPU. Faster Whisper used CPU int8 with beam size 5. Whisper.cpp ran through the pwhisper Windows wheel with its standard tiny.en model. Each transcription was timed after the model files were already downloaded. Word error rate was calculated against the exact subtitle text. This is a clean speech test, not a universal accuracy ranking. Officially, both projects run OpenAI's Whisper model family rather than a proprietary hosted service. OpenAI describes Whisper as a general-purpose model for multilingual recognition, translation, and language identification. Its code and model weights are released under the MIT license. The Faster Whisper project says it re-implements Whisper with C Translate 2 and can use 8-bit quantization on CPU or GPU. Its own benchmark shows performance depends heavily on the model, precision, batch size, and hardware. The Whisper.cpp project emphasizes a dependency-light C and C++ core, CPU support, integer quantization, and a long list of platforms. Those are project claims. The numbers in this episode are separate measurements from one Windows CPU. The measured accuracy was effectively a tie. Both outputs had a word error rate of 3.98% after normalization. Most differences were punctuation, capitalization, and number formatting. Both recognized gamma, Canva, credits, the 8-slide brief, and the surrounding sentences well enough for a useful draft. The final phrase was cut because the test file ended at 75 seconds, so both systems faced the same boundary. Whisper.cpp transcribed the file in 3.86 seconds. Faster Whisper took 4.45 seconds. That gives real-time factors of about 0.051 and 0.059. In plain language, both processed more than 16 times faster than playback. Whisper.cpp was about 13% faster in the single run. Do not convert that into a universal claim. The Faster Whisper documentation shows batching can materially change throughput, especially on larger workloads. The model files were almost the same size, about 74 megabytes for each tiny English model. The surrounding setup was not the same. pwhisper installed as a pre-built Windows wheel and downloaded one ggml model file. That made the path from install to transcript comparatively direct. Its project also supports building from source when you want CUDA, Vulkan, Core ML, or other backends. Faster Whisper installed C Translate 2, PyAv, tokenizers, the Hugging Face client, and supporting Python packages. In return, it accepted common audio formats without requiring a separate system FFmpeg install, because PyAv bundles the decoding libraries. For a Python application, those dependencies are reasonable. For a small desktop script that only needs a transcript, Whisper.cpp feels leaner. Speed on one short file is not the whole decision. Faster Whisper exposes word-level timestamps, a Silero voice activity detection filter, batch transcription, language detection, and direct access to each segment as a Python generator. That makes it easier to build a meeting pipeline that trims silence, creates subtitles, indexes quotes, or sends structured results into another application. It also supports converted distill Whisper checkpoints and multiple compute types. The practical warning is configuration. A benchmark changes when you change beam size, precision, batching, VAD, model version, or CUDA libraries. Record those settings with every result. Also remember that a generator does not start work until you iterate through it. That detail can produce misleading timing if the script only measures the function call. Whisper.cpp is the stronger foundation when portability matters more than Python convenience. The official project supports Windows, Mac OS, Linux, mobile platforms, WebAssembly, Raspberry Pi, and several GPU backends. Its model format packages the weights and related data into a single file. The core can be embedded in a native application without shipping a full Python environment. For this test, the whisper binding provided a simple Python API and automatically downloaded the model. That convenience comes from the binding, not only from the C++ core. If you need a polished business app, you still have to build file handling, speaker labels, review screens, exports, and error recovery. Neither option is a complete meeting assistant by itself. There is no normal free versus paid feature gate here. Faster Whisper, CPP, whisper, and the original Whisper code use permissive MIT licenses according to their repositories. That generally allows commercial use when you follow the license notice requirements. But this is not legal advice. Your actual costs are the computer, storage, integration time, support, and any review needed for production. Local processing improves control because the audio does not need to be uploaded to a transcription provider. It does not automatically make a workflow compliant. Meeting recording and employee monitoring rules vary by location. Get consent where required. Protect the audio and transcript, define retention, and test names and specialist terminology before using automatic text as an official record. My final verdict is clear. Choose Whisper. CPP when you want the smallest practical local transcriber, need to embed speech recognition outside Python, or care about running across many device types. It won this clean CPU sample on speed while matching accuracy. Choose Faster Whisper when you need batching, VAD, word timestamps, converted models, or tight integration with a Python data workflow. For occasional office recordings, Whisper. CPP is the simpler starting point. For a production transcription service, Faster Whisper is usually the more flexible engineering platform. Test both on your real accents, microphones, noise, and vocabulary before committing. The benchmark script and official sources are listed below.